As I mentioned in the last video, we may have an F statistic, it might even be a large F statistic, but it doesn't tell us about effect size. We've been using Cohen's d to calculate effect size and R squared with the t-test. We use something different with ANOVA. So with ANOVA, we use something called eta squared. And the way that we interpret eta squared, it's the percent of the variance accounted for by the treatment. And we find eta squared in ANOVA by taking the sums of squares between and dividing it by the sums of squares total. So let's do that for this last study that we just conducted. In the last study, our sums of squares between were 30, and our sums of squares within was 46. So we just do a simple division. We do a simple calculation to figure out eta squared. 46 goes into 30.65. So we can interpret this to say that 65% of the variance between the means can be attributed to the treatment, the placing of people into different rooms with different temperatures. That is eta squared. Now you might be wondering, well, how do we interpret eta squared? Eta squared is interpreted in the following ways. 0.01 would indicate a small effect. 0.13 and above is a medium effect. 0.25 and above is a large effect. So in our study, eta squared of 0.65 is really quite large, isn't it? So that's eta squared, and that is how we figure effect size for ANOVA. In the last video, I'm going to talk with you about something called post hoc tests and why they're important, and they're really important in ANOVA. See you there.